Hello again. This is Mr. Roundy bringing you another wonderful math lesson. Today's lesson is on greatest common factors and finding those greatest common factors with prime factorization. Glad you could join me. Let's get started. Today's objective is, after this video, you should be able to find the greatest common factor of two numbers using prime factorization as the method. Sounds simple? Let's take a look. Just a little bit of review. First off, one thing you've got to know before we can do prime factorization is you got to know what a prime number is. Prime numbers are numbers that only have one and itself as factors. Something else you should know is what a composite number is. Now, composite numbers are numbers that have many factors. We're going to be dealing with both types of numbers as we learn about how to solve for the greatest common factor using prime factorization. So here we have a chart with prime numbers 1 through 100. All the prime numbers have been circled. So some of our basic ones, 2, 3, 5, 7, 11, 13, 17, 19. I don't think you'll have to work with anything too high on the list. But just for reference, you can find a nice list of prime numbers or a chart just like the one I have by doing a quick Google search for prime numbers charts. Now, one of the best ways to go over prime factorization is just to show you an example. So here we have two numbers, 36 and 30. We start prime factorization by listing two numbers that we can think of that would multiply to make 36 and 30. So we come up with, for 36, 4 times 9, and for 30, 6 times 5. Now we're going to break those down even further. We start with looking at 4 and think of two numbers that can multiply to equal 4 and two numbers that can multiply to equal 9. We do the same thing for 6 and 5. Well, 4 can be broken down into 2 times 2. 9 can be broken down into 3 times 3. 6 can be broken down into 2 times 3, and 5 can't be broken down because it's already prime. 2 is a prime number, 3 is a prime number, and 5 is a prime number. So we have broken down 36 and 30 into its prime numbers that go into making it. So down below, I've listed those prime numbers for each of the given numbers that we have. So 36 is made up of 2 times 2 times 3 times 3. And 30 is made up of the prime numbers 2 times 3 times 5. Now you'll notice that I've got a couple of these numbers highlighted on each side. Well, what I'm doing is I'm finding common numbers that are in both of my prime factorizations. So both 36 and 30 have a 2 as one of their prime factors. Notice that the second 2 is not highlighted. That's because I don't have a matching 2 for it on the other side with 30. There's only 1 2 and 1 2. If I wanted to highlight or select this 2, there would have to be another 2 to partner it with over here with 30. I have a 3 and a 3 because those two can partner up. This 3 doesn't have a partner. And notice that there's no 5 on this side, so 5 doesn't have a partner either. The next step is to take those partners that I found and write them one time. So I have a pair of 2's, so I write 2. I have a pair of 3's, so I write 3. And I multiply those together, which equals 6, which gives me a greatest common factor of 6 for 36 and 30. Now, let's go ahead and get some more practice. For our next example, let's go ahead and do the prime factorization for 48 and 72. So I'm going to break down 48 into two numbers that I know will multiply together to make 48. The first ones that come to mind are 6 and 8. Any combination would work, but I've chosen 6 and 8. So I'm going to now break down my 6 into 2 times 3 and break down my 8 into 2 times 4. Now 4 will break down again into 2 times 2. I stop once they have all reached a prime number. So 2, 3, 2, 2, 2 are all prime numbers. Now I'm going to go over to the other side for 72. 72, I think, okay, how about 8 times 9? 8 will break down into 4 times 2, and 4 will break down into 2 times 2. 9 will break down into 3 times 3. Now all my numbers are prime. 2, 2, 2, 3, and 3. Now let's list the prime factorization for each number. 48 equals 2 times 3 times 2 times 2 times 2. And 72 equals 2 times 2 times 2 times 3 times 3. Now I'm going to match up my pairs. I've got a pair of 2's, a pair of 2's, another pair of 2's. The last one doesn't have a 2 to pair with, so I'm not going to circle it. I also have a 3 and a 3 that pair up. This last 3 doesn't have one to pair with. Now, for every pair, I write that number one time. So, for my first pair of 2's, I'm going to write 2, and a second pair of 2's times 2, and my third pair of 2's times 2, and my pair of 3's times 3. Now if I do 2 times 2 is 4, times 2 is 8, and 8 times 3 gets me a GCF of 24. Let's take a look at one more. How about finding the GCF of 28 and 42? Let's break down 28. 28, I know, will be 4 times 7. 4 will break down into 2 times 2. 7 doesn't break down. It's already prime. Now we go to 42. I think of two numbers that can multiply for 42. I think of 6 and 7. Break down 6 into 2 times 3. 7 I don't break down because it's already prime. So now I write down 28, and it is 2 times 2 times 7. That's the prime factorization for 28. 42 is 2 times 3 times 7. Now I'm going to circle any matches. I have a pair of 2's. This 2 doesn't have anything to pair with. The 7's also are a pair. 3 doesn't have a pair, and this other 2 doesn't have a pair. So now for every pair I write that number one time. So I have a pair of 2's, so I write it once, 2. And I have a pair of 7's, so I write it once, 7. And I multiply those together. and that equals 14. So the GCF for this problem is 14. Let's do one last problem. Let's find the GCF using prime factorization for 16 and 24. 16 will break down into 4 times 4. 24 can be broken down into 6 times 4. 4 will break down into 2 times 2, and this 4 will break down into 2 times 2. 6 will break down into 2 times 3, and 4 will break down into 2 times 2. Now let's list my prime factorization. 2 times 2 times 2 times 2. And on 24, 2 times 3 times 2 times 2. Now let's circle our pairs. I've got a pair of 2's, another pair of 2's, and another pair of 2's. My 3 does not have anything to pair with, and this final 2 doesn't have anything to pair with. So now for each pair, I write that number one time. So I have my first pair of 2's, I write it once. My second pair of 2's, I write it again. And my third pair of 2's, I write it again. Now I do 2 times 2 is 4, and 4 times 2 equals 8. And my GCF for 16 and 24 is 8. Let's go back and review our objectives. The objective in this video was that after the video, you should be able to find the greatest common factor of two numbers using prime factorization as the method. So, after reviewing all our examples, hopefully this is something you're able to do. If you're having any trouble, I suggest you go back and watch the examples one more time and do the work with me. I'm glad you could watch, and I hope you learned something. Have a great day.